All right, guys, today we're going to do something brand new for you guys. It's called finding limits numerically and graphically. Finding limits is, the course you're taking is called pre-calculus, and this is truly pre-calculus. Really, it's like calculus concepts. So really pay attention to the video. Probably need to take notes today on this video. I'm going to watch it more than once. It's not going to be very long, but the definitions in here are critical for the next few weeks. All right, definition of a limit. What they're going to do and what limits are, they're going to give you a function like this and basically ask you what happens to that function as it gets closer to a certain x. Like, let's say they're taking values near 2. So we're going to get closer and closer to 2 without actually plugging into. That's a key. It does not equal to, just to see what's happening with the function. So what we did here is I took like a calculator table and started at 1 and got closer and closer to 2. As you can see, we went all the way to 1.999. Did the same thing for the other side, starting at 3 and getting closer and closer, going the other direction, getting closer and closer to 2. And look what I got in both cases. When I went closer from the lower side, I got 3.997. When I came in from the upper side, I got 4.003. So they're basically getting closer and closer to 4. The values are approaching 4 as you come in from each side of 2, meaning I came from less than 2 over here, I came from greater than 2 over here, and each time I'm doing that, I'm getting closer and closer to 4. All right, now, you can also look at it on a graph. Okay, so I'm looking at the graph. If I come from this side, it's getting closer and closer to, there's 4 right there. And if I look at this side, I'm getting closer and closer to 4. So the way we read this is as x approaches 2, down here, as x approaches 2, f of x or y is getting closer and closer to 4. Okay, true definition. If we write it, here's how we're going to write them, by the way. We're going to say, okay, the limit of f of x, the function, as x approaches a, whatever x is approaching that number, is going to equal L. Read it like this. The limit of f of x as x approaches a equals L. If we can make the values of f of x so close to L, as close to L as we like, by taking x eventually close to a, but not equal to a, it's key. You cannot use equal to a in there. In our language, maybe a little easier to understand. Look at the print in white here. This says that the value of f of x get closer and closer to some number L as x get closer and closer to the number a from either side of a. Remember, we cannot equal a. And that's what the yellow says. But x does not equal a means that in finding the limit of f of x as x approaches a, we can never consider x equals a. And there's reasons for that. The only thing that matters is how f is defined as we get closer and closer to a. Okay, it says estimate the value of the following limit by making a table of values. Check your work with the graph. Okay, so here's our function. It says limit as x approaches 1. Now notice, you can't actually plug in 1 because it would make your denominator 0, which is why we don't ever use x equals that number. So I'm going to approach it from both sides. If I approach it from less than 1, all right, I'm getting 0.99999. If I approach it from greater than 1, look what I'm getting. If I'm approaching it less than 1, I get this value, 0.50025. If I go greater than 1 and come down to it, I'm getting 0.4999975. So both of those are getting closer and closer to the answer where I pointed my arrows to right here. They're both getting closer and closer to 0.5. So we would say the limit as x approaches 1 of x minus 1 over x squared minus 1 is 0.5. Now, if I look at the graph, which I took a picture of the graph down here, and I'm looking as x, and that's from 0 to 2, by the way. All right, so I'm going from 0 to 2, and if coming from this side, getting closer and closer to 1, look what I get. I get 0.5. And if I zoom in further, go from between 0.9 and 1.1, which is really close, same thing happens. All right, look at another one. Find the limit as t approaches 0 of square root of t squared plus 9 minus 3 over t squared. So I did the same thing. This time, because there's a square root in my numerator with a square, because there's t squared, everything's squared, I can literally plug in a plus or a minus, and I'm going to get the same value. Okay, that's why those say plus or minus right there. No matter which side you take, you're going to get the same number because all the t's are squared. All right, so as I start at 1, and work my way down or up, both sides here. Look what I'm getting closer and closer to. By the time I get to 0.01, basically away from 0, I'm at 0.16667. And if you were to change that to a fraction, by the way, I put the answer right there as 1/6 because 1/6 as a decimal is 0.166. It just repeats, okay? So eventually it rounds to 0.166667. So that's the limit. As you get closer and closer to 0, now notice again, I can't plug in 0 in there because it'd make the denominator 0. So that's why we never include, that's one reason why we never include the actual value. Some limits don't exist. Right, this is one of them. Piecewise, sometimes, not every time, but this time. Let's see. It says this one, if I took the limit of that function as x approached 0, look what happens. As I'm getting closer and closer to 0 here, I'm getting closer and closer to 0. But if I'm approaching 0 coming this direction, I'm getting closer and closer to 1. It's not the same value. And because it's not the same value, that doesn't mean there's not a limit there. One more case where that happens. It says find the limit as x approaches 0 of 1 over x squared if it exists. That's a hint. All right, so think about it again. You can't plug in 0 because, make the bottom 0. And because it's x squared, the same thing is going to happen if I approach from the left side or the right side. Doesn't really matter. So those are my plus or minuses. Look what happens as I start getting closer and closer to 0. My numbers get bigger and bigger and bigger and bigger. And if I got even closer, it would get even bigger. Look what's happened on the graph. If I'm approaching from the left side, graph's going up, 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 up forever. From the right side, it's going up, up, up forever. So it's approaching infinity. And it's not that we don't say infinity is not a number, but there is no, they're approaching not a number, not a true single value. Okay, so it's approaching positive infinity. So that's it. Hope that makes some sense. See you in class tomorrow.